Okay, I'm going to go over how to solve any quadratic equation. So when it says solving any quadratic equation, yes, this is any quadratic that has an equal sign. Not just factoring it, but this is how to put it into the calculator. If it is supposed to be equal to 0, but you have imaginary roots, the steps to doing that. And really, it's mainly either putting this in the calculator to find the zeros or using the quadratic formula. And with those two, you can solve any type of quadratic equation. So the first thing we're going to do for this one is I need to get everything on the left side. So I've got 2x squared plus 3x equals 5. So all I need to do is subtract 5 from both sides, which gives me 2x squared plus 3x minus 5 equals 0. And now I've got something that I can graph pretty easily and get some solutions for. So on this, we will go to the y equals, and I'm just going to put this quadratic equation in there. So 2x squared plus 3x minus 5 equals, we've got the y on the other side. So 2x squared plus 3x minus 5. And then we'll just check the graph because we're going to do a quick representation of it. So I'm not going into my table and getting exact points or anything. This is just a quick, what does it look like? So we have an idea of about where it should cross, and we are able to decide, does this cross the x-axis, which it does. So since we know that it crosses the x-axis, to get our solutions, remember it says that s equals 0. If it said equals 1, like if I left it as 2x squared plus 3x equals 5, I'd need to have a line that was 5 on there and see where it crossed that. But there's a calculation function here when I do second trace. Number 2 is going to find my zeros. So when I do that, then I've got something that'll find my zeros for me. So it wants to know left bound. So make sure you're on the left side. And I'll put a little arrow up here. Then right bound. And so then my guess would be right in between that. And so it gives me negative 2.50. So I know it's the right point because my y value is 0. And that's going to be a negative 2.5. But there's more than one 0 on this. So as I'm looking at it, I need to do that second trace 2 again. Down to 2. And left bound is over here. Right bound is over here. And should be able to get kind of close. Yeah, and it still finds it. So a positive 1. So it's not an ordered pair because we're not putting it in parentheses. This is just a list of my two solutions to this quadratic equation when the whole thing is set equal to 0. So for that, you can use the calculator, quickly find that for any equation. Let's look at the next one. I've got 3x squared equals 3x minus 7. Now, if you were to take this and put it in just as is, 3x, not to the negative first, 3x squared, and then maybe on the next line put 3x minus 7. When I graph it, what's going to happen is I get my parabola there for 3x squared, and then I get a line that doesn't touch that. So even that right there tells me, okay, there's not going to be any solution because Just like my parallel lines when I would do straight lines for a system of equations, they don't ever touch, so there's no solutions. Okay, and I'll show you the same thing if I were to just put it as my y equals all on one side. If I subtract this whole thing, so minus 3x plus 7 cancels all that out and moves it to the other side, get 3x squared minus 3x plus 7, and then there's nothing left on that other side, so it's equal to 0. So if I put that in there, 3x squared minus 3x plus 7, then when I do the graph, we can tell it's not going to cross. So again, we'll draw a quick representation of it. So for this, it gives me just 1. That's up there, a little ways away. And since it doesn't cross 0, that means I'm not going to have any real solutions to it. So since there's no real solutions, I can't go second trace and find a 0 because there's not one. So it's going to look, and it's looking for a sign change there and not going to work for me. So what I've got to do then is I'm going to use the quadratic formula. Remember, that is negative b plus or minus the square root of b squared minus 4 times a times c over 2a. So remember, this is my a value, b value, and c value. So 3, negative 3, and 7. So a negative 3 changes to a positive 3, plus or minus the square root of negative 3 squared minus 4 times a, which is 3, and c, which is 7. All that over 2 times 3. Okay, so as I solve this, and that's going to be x equals those. So x is equal to 3 plus or minus the square root of negative 3 squared, which is 9. 4 times 3 is 12, times 7 gives me a negative 84 over 2 times 3, which is 6. Next, I'm subtracting 9 minus 84, and I'm going to get a negative 75. So that's my key to knowing, okay, these aren't going to be any real roots. So I've got a unsimplified version of the answer here. Need to do some simplifying if I can. One thing I know I can do is pull out that negative 1 and get I for that. But let's see what else we can do. So if I have negative 75, I'll pull out that negative 1. That becomes an I. Then for 75, well, I know 25 and 3 would equal 75. And 25 splits up to 5 and 5, which also combine together to put a 5 on the outside. Then that 3 is the only thing left that stays. So I end up with 3 plus or minus 5 came out, the I came out, and the 3 then stays in over 6. And because I can't divide every part of that by anything, then it just stays as this. So 3 plus or minus 5 times I times square root of 3, all that over 6. So that would be my two solutions. The reason those are solutions is because I can still find roots to these. And if I were to take and put this in root form, so x minus the whole thing, 3 plus 5i times the square root of 3 over 6, and then just my root form, x minus 3 minus 5i square root of 3 over 6. What would happen is, as I multiplied all that out back together, it would actually get me back to this right here. So even though they're imaginary roots, if I recombine them, it works both ways for that. So that's the reason that we are able to go and find those. But for you, we just need this as my answer here. Okay, on the back side, let's take this and quickly put it into my calculator. So I have a negative 3x squared plus 10x minus 5. And I'll graph it. Let's see what we come up with. Okay, I come up with a graph that does cross the x-axis. So second trace 2. And I'll do left bound, right bound, guess. Okay, so remember it said we're finding the answer to any quadratic. That means you could have ones where you get this weird decimal number. So when that happens, for that 0, we're just going to put down to the thousandth. So first solution I have is 0.6125, so that'd be 3, rounds up. And the next solution I have, second trace 2. Left bound would be there. Make sure I get to the right side there. If I guess right there, 2.721. So, because this is looking at solving any type, you will get some decimal numbers here. Okay, the last thing we'll look at, you can use this to find the maximum of this. So since it's negative, I know it'll be upside down. But again, we'll take and put it in for this. So in the calculator, I'd put negative 2x squared plus 3x minus 4. Check our graph. So even though I don't have any zeros, it's just wanting to know the maximum point of this. So to find the maximum, second trace, and I've got a maximum there. All I'm going to have to do is this is the left of the maximum. That's to the right. That's my guess. And it finds this is the highest point. So I would put that as an ordered pair. So my x value was 0.750, because that 999 over and over again, basically set 0.750 or 3/4. And then negative 2.875, which would also be a regular fraction as well. But that's putting that there as my maximum. Last thing, when I'm finding the x-intercepts, this is really technically just doing the same thing. Only if it's wanting to find the x-intercepts, then it would only be real solutions. So if I had a graph like this on number 4, it doesn't cross the x-axis, then obviously there's actually no x-intercepts. Finding the roots for the equal 0, I get those imaginary just because of the way it works out. But for x-intercepts, I believe this one would find it. Your you're doing the exact same steps there as we did up here, putting it into the calculator, finding the zero. So same thing on that step, and you would get your answers there. Okay, that is that. You've got some homework on it, doing each of these steps. Close that off there. But a lot of it you'll be able to do in the calculator. Those imaginary roots, though, you're working through that quadratic formula.